Hydrogen, the #1 element. This video is about the history and development of hydrogen. We will recreate some breakthrough experiment in its history, from its discovery until now that hydrogen is one of the biggest promise in the renewable energy world. Let's have it. Hello everyone and welcome to another video of Topics Basics. As mentioned, we are going to recreate 3 major breakthrough experiments in the history of hydrogen. To do so, I have my friend Dr. Quentin Daniel helping me.
Hello everyone.
So, we recreate the experiment for discovery of hydrogen, water electrolysis, and we finish with one of the most promising and renewable way of hydrogen production, water splitting with a catalyst. When it comes to the last point, Dr. Quentin is an expert. He did his PhD on the same topic on the other side of this building, and his PhD thesis is actually one of the main references for the script of this video. When I was writing, I asked him to join me on the video, and he kindly accepted. Thank you for that.
You're welcome.
So, let's do it. The first experiment is discovery of hydrogen by Henry Cavendish.
And to do so, we'll use a metal and oil of vitriol, which is nowadays called sulfuric acid. But I think that Cavendish used also different type of material to use this experiment.
He used 3 metals, zinc, iron and tin as his metals, and oil of vitriol and a spirit of salt as his acids.
So here for this experiment, we'll use zinc powder that I just put here on the plate now. And I will put sulfuric acid on it. Which is very important here is that this experiment is exothermic, so it produces a lot of heat. On the zinc, we have always a little bit of residue of water, so we'll have water that will evaporate as a smoke, let's say, and then we'll see some bubbles forming on the top of the zinc. That will be our hydrogen.
Okay.
So here we can see bubbling still ongoing, which is the hydrogen which is releasing from the zinc.
Yeah, so there's a reaction of zinc powder and sulfuric acid, which is pretty simple reaction. It produces zinc sulfide and hydrogen. This demonstration shows how he produced hydrogen from reaction of an acid and a metal. He published this result together with lots of other detailed experiments in a comprehensive paper in 1766 and read it in 3 different Royal Society meetings. He repeated this experiment with different concentration of acids and basically saw the same thing. After production of the gas, he collected it and did further studies on it. To do further studies, he needed to transfer the gas between different containers. This was a tedious work, as he reported in his publication. One of the further studies that he did was that he mixed different ratio of inflammable air with common air and he put them on fire. As he increased the ratio of inflammable air, he saw that the combustion process diminished. That was probably one of the explanations that why this gas is named inflammable air. Later in 1783, inflammable air was named hydrogen. This was after production of water from burning process of inflammable air, which was basically reaction of hydrogen and oxygen. Cavendish did this experiment but could not explain it properly. Antonio Lavoisier did the experiment and explained it correctly and came up with the name hydrogen, meaning water creator, a combination of hydro, water, and gene creator. The second experiment is water electrolysis. It's also famous as Nicholson experiment. It happened after discovery of battery by Volta in 1800. It mentioned in one of the first video in this channel that discovery of battery by Volta helped a lot in discovery of several elements. But this is another example of using Volta battery in science development. So to recreate his experiment, we have a 9-volt battery here. we have 2 cables. Water, we put some salt in it to make it conductive. And we have 2 test tubes. Now we put the setup here and then we come back. It takes some minutes.
So now our setup is done. Here I have a negative pole of my battery which is connected to this test tube. Here the positive pole of the battery which is connected to the test tube. Now I will close the loops of the battery, and here, as we can see, we have a production of bubbles on both sides of the 2 different test tubes. On this test tube which is connected to the positive pole, we have oxygen which is produced. On the negative side, the hydrogen. So the battery here is giving us energy to break the water molecule into oxygen and hydrogen.
Okay, and now we wait for some time, then we can have some hydrogen on this tube, then we can play with it.
Perfect.
So now the reaction went on for quite some time, and we have some hydrogen here, and we can try to make a fire out of it. But that it was named inflammable air by the genius Cavendish, it basically doesn't burn, it's like an explosion. You should not try this at home. Oop. That was all of it. To mention Nicholson experiment as experiment for discovery of electrolysis might not be 100% true. Decades before Nicholson experiment, these 2 gentlemen, Truthwitz and Damon, did similar work and published it. Several resources claim that Nicholson was well aware of it, including in this paper that is claimed and explained in detail. There was a difference between theirs and Nicholson experiment. They used electrostatic power source based on friction for water electrolysis. As a result, they saw a spark of electricity instead of a continuous power. So, hydrogen and oxygen were produced, but not as complete and continuous as in Nicholson experiment. So, their discovery was not well accepted. At their time, battery was not discovered yet. The third experiment that is a modern way of producing hydrogen is water splitting with the help of a catalyst. It is a chemically driven water oxidation reaction. What we do is that basically we put a chemical inside the solution which is electrochemically active. Through its reduction, it produces energy that can be used in splitting water into oxygen and hydrogen. Now Quentin continues.
Okay, thank you. So first, we'll use cerium-4 here, also called CAN. This has a potential of 1.7 volt. So this will be used as our battery technically. So first of all, I will take some of it. I will fill it in this test tube. So here technically I'm just putting my battery inside my test tube. I will put some waters inside and make it dissolve. Okay, here as you can see on the video, we have 1.7 volt inside the solution. But however, you don't really see any bubbles of oxygen that is produced. This means that this 1.7 volt here that we have inside our solution is not enough to do water oxidation.
This is what is happening. We have an electrochemical reaction. The reduction of cerium-4 plus to cerium-3 plus is giving us 1.7 volt energy. That is desirable for breaking the bonds in water molecule and split it into oxygen and protons. The reaction with 1.23 volt potential. But due to the resistance, this wouldn't happen until we use the catalyst. That is why we don't see the bubbles now.
What we need now, in fact, is to have a catalyst. Majid, hold me that.
Yeah.
Thank you. What we need, in fact, now is to have a catalyst that will decrease the energy that we need to do water oxidation. Today we'll use a Ruthenium complex, but you can find the formula here. First of all, I need to dissolve also this Ruthenium complex inside the solution. This complex is not water soluble, so first I will dissolve it in another solvent, acetonitrile. Since it's a catalyst, I just need a little piece of it. I will try to take these little nuggets, if I can.
You can go on the camera to get it.
Here we go. Oh, so we have very small amount. Then what I will do, I will dissolve it in small amount of acetonitrile to make it soluble. So here technically what we will do is water oxidation in homogeneous phase, so just in aqueous phase, in water. Up. Little bit of acetonitrile. Dissolve everything by stirring technically. Okay. So now I have my catalyst in this solution, and here I have my cerium-4, which is my battery. I will now mix my catalyst inside the cerium-4, and what will happen is a production of oxygen. Here. So here what you can see, all the bubbles is the production of oxygen. In the same time, you can see that the yellow solution of the cerium-4 is being consumed. So technically, I'm using the energy of my battery, I'm consuming the cerium-4 here. And this reaction will produce oxygen and also then protons, which is very important for the full reaction of water oxidation and water splitting.
Water splitting reaction consists of two half reactions: production of oxygen and protons, and production of hydrogen from protons. The first one, production of oxygen, is the hardest one, and so-called the bottleneck of overall water splitting reaction. It is a 4-electron oxidation reaction, so a source has to produce 4 electrons that this reaction happens, which is not easy. That is why we use the catalyst. Use of these types of catalysts for water oxidation reaction started in 1982 after discovery of it. It started at group of Professor Mayer at University of North Carolina after publication of this paper. In this experiment, we use this ruthenium-based catalyst for our reaction. The catalyst goes through a cycle of different reactions where in the last part, our favorite part happened, water oxidation. After several cycles, the catalyst will be deactivated or decomposed. The turnover number that is specific for each catalyst is implying the number of times that the molecule can perform the reaction before deactivation or decomposition. The more the better, of course. Now there is one question remaining. Why do we need to produce hydrogen? Is it important at all? Hydrogen is an energy carrier, not a source of energy. So it can be produced in different pathways, as we saw in this video, and transfer the energy for a specific application with zero carbon emission at the end usage. Nowadays, it seems like that there is a new announcement every day about hydrogen for energy utilization and automobility. From hydrogen cars, like this little car that can be used for education purposes, to hydrogen airplanes. Hydrogen has this potential to quickly integrate into most existing energy and transport systems while significantly reducing air pollution. Many national and international organizations are formed to calculate and investigate the hydrogen economy and the impact it can make. Currently, using renewable electricity as driving force for water splitting is the most established and efficient way of hydrogen production. It is a modern way of our second experiment. So the electricity that is produced through solar, wind or hydropower will be used for water electrolysis to produce hydrogen. Our third experiment, water splitting through a chemical reaction with the help of a catalyst, is the ultimate green way of hydrogen production. Although it is not the most efficient way of hydrogen production, but research on the highest level are paving the pathway to solve it. With that, I would like to finish here. Please let me know if you have any comment or any question. Thank you for watching and see you in the next video.